In this video, we are going to look at the intermediate value theorem. And this is what the theorem tells us. If f is continuous on a closed interval from a to b, and f of a is not equal to f of b, and k is any number between f of a and f of b, then there is at least one number c in the closed interval from a to b, such that f of c is equal to k. There's a lot to unpack there, but what this problem says is if we are continuous on a closed interval from a to b, so maybe we have f of a, maybe it's defined somewhere up here. So this is f of a. And we have f of b. Maybe it's somewhere down here. There's nothing that forces it to be smaller. And we know that this function is continuous. Right? So on the closed interval from a to b. So remember, continuous means I can draw a line from here to here without lifting up my writing utensil. So it could do all kinds of strange things. I just can't lift up my writing utensil. It could go straight there. Any kind of picture that we might have that is continuous, right? So it's continuous. Now, if k is some number between f of a and f of b, so this is the value k, then we are guaranteed to have at least one number c such that f at c is equal to k. And so if we were to draw the picture, I don't know what this picture is going to look like. Maybe it looks like that. We are guaranteed that somewhere, at least one spot, there's some number c where the function value at c is equal to k. Now, on this graph that I drew, there happened to be more than one, right? So it says there's at least one number c. Maybe it's only one, but it could also be more than one. All right, so let's use this intermediate value theorem in a problem. So use the intermediate value theorem to prove there is at least one zero of f of x in the interval from 0 to 1. So let's first note that f of x is continuous on 0, 1, since it is a polynomial. And polynomials are continuous everywhere. Also, observe that our function value at 0 is 3, and our function value at 1 is -1. Since 0 is between 3 and -1, okay, so it's between f of 0 and f of 1. That's between the function values at the two endpoints. Then there must be at least one value c in the interval from 0 to 1 with f of c equals 0 by the intermediate value theorem. All right, so we can be certain that that kind of value exists, and we are able to find that without so finding it might take a little bit more work. We'd have to solve a cubic polynomial, but we know that there is a root somewhere in that interval. All right, and we will see you next time.